the total lunar eclipse. My name is Kevin Schindler, and I'm the historian and public information officer here at Lowell Observatory. And I'm joined by John Compton, John is a geologist. He's an educator. If you've ever been up to Lowell and seen a program, it happened because of him, because he scheduled staff to be here. So we're going to be with you for the next several hours, talking about this exciting eclipse event. And we've got some clouds here in Flagstaff, but heck, one way or the other, we're going to celebrate the eclipse and what's going to be happening. So we want to kick it off first with a video by Rezi Balko, one of our lead educators, and she's going to talk about just what an eclipse is.
Hello, I'm Rezi, Public Program Supervisor here at Lowell Observatory, and I am here to answer the question, what is a lunar eclipse? So we have our lunar eclipse happening tonight. We're moving closer and closer to it. As the moon rises, it's going to be moving into the Earth's umbra, the darkest part of the Earth's shadow. And here in Flagstaff, it's going to be all the way in that umbra at the darkest point in that shadow, a little bit after 9 p.m. All right, so let's go ahead and jump on in. What is a lunar eclipse? Well, to talk about lunar eclipses, it helps to understand the phases of the moon. So down here, I have a sun, I have an Earth, that's us. I've got a moon right here. And so basically, let's start with talking about moon phases. When I was a kid, I thought that the moon phases were caused by the Earth's shadow. Here would be like a round shadow. I thought, okay, you've got a crescent moon, here's the Earth's shadow, bam, beautiful crescent. But that doesn't actually make sense, right? Because we also get a half moon, and to get a half moon, you have to have this like straight line running through the moon. Well, the Earth is round, so we don't have any straight lines, right? Our shadow would be a circle. And so moon phases, right, they're not caused by the Earth's shadow, they're caused by the moon's shadow. We have our sun right here, it's shining light this way, so I'll draw a little arrow, and that's the one that's going to light up part of the moon. And then the moon's own shadow, right? There's no sun casting light down here. So the moon's own shadow is what causes that dark part of the moon. So let's go ahead and introduce Earth here. So for example, right here, if you're on Earth, you would not see a moon, and the moon would be up in the daytime. That's a new moon. As we come to over here, you would only be able to see a little teensy sliver of the moon. From right here, if you're on Earth, you would see half of the moon. From over here, you would see a full moon, and it keeps going with half a moon, another crescent, and then new moon. So those are how the moon phases work. They're caused by the moon's shadow, not the Earth's shadow, as the sun is shining on only half of the moon. If that's the case though, then when we're at this point right here, this full moon, you would think, well then wouldn't Earth cast a shadow? It's between the sun and the moon. But we're working right now with like a piece of paper, right? This is two-dimensional space. We live in three-dimensional space. That means that we don't just go like side to side or side to side, we can also go up and down. And this is what happens, right? The moon is orbiting around the Earth. It's making a little circle, but he's not orbiting on a perfect flat plane. If the Earth is up here a little bit, our moon is sometimes further up, sometimes it's further down, and it kind of circles more like this. So that means for our average full moon, the Earth is actually maybe up here a little bit. And so the sun is still gonna shine directly on the moon, light up the whole thing for us, we still see a full moon. Or maybe Earth's down here and the moon's a little bit up here. But when we get a lunar eclipse, they are on the same plane. They are on this exact same level, and that means that our sunlight now does pass through the Earth's shadow does get cast on the moon. So this is then where we get a lunar eclipse as our shadow moves over that moon. Now, this is a dark circle, right? And you'll notice when we're looking at our lunar eclipse tonight that the moon doesn't just look dark, it actually looks red. So let's talk about where we get that red coloration. So our sun is shining light on Earth, right? And it's casting a shadow out on the moon. So we've got our sunlight coming, pew, sunlight. Our light is being filtered through the side of the Earth. And what's happening along here? This would be daytime on this side, nighttime on this side. So day, because that's where the sun is. Night, because this is where just like black space is. So that means that the sunlight is coming through these bits right here where day and night meet. And what's happening on Earth where day and night meet? Well, we're having sunsets. Light scatters. Different wavelengths of light, different colors, they scatter different amounts. You can see this visual that we're gonna put up here in just a second, and you can see that the blue light, which has a shorter wavelength, it scatters more than the red light. So this is what causes our sunsets, right? All of the blue light that is normally filling up our whole atmosphere is scattered around, so we get this beautiful blue sky. All of that gets scattered away, and instead we start to see red, and that's what happens at sunset. Now, because the sun's light is coming at the moon from this direction, it's hitting that sunset part, and the blue light is like going like pew in this direction. And then the other colors, you know, they're going less and less as we go through like green and then like yellow. And then what ends up happening is the red light comes through this way, and it's all that remains. So instead of getting a dark moon as we move through Earth's umbra, the darkest part of Earth's shadow, we actually get a red moon. And what I think is neat about this is that, I think it was NASA put it this way last year for a lunar eclipse. They said that the moon is red because we're looking through all of Earth's sunsets all at once. So not only are we looking at our own shadow when we look at this lunar eclipse, we're also looking at all of the Earth's sunsets, all of the Earth's sunrises that are going on at that moment, all at once, projected onto the moon. So that's where we'll get that red coloration.
Hey, we're back. I hope you enjoyed the video. There's more to come throughout the night, but we're back to kind of chat with you and answer questions and talk about the moon with our fellow lunatics. If you've listened to the Star Stuff podcast through Lowell Observatory, you'll know that I'm a big fan of the moon. While people here might want to destroy it sometimes, I advocate for Luna. But yeah, back here, answering questions and chatting.
And then we have a lot of great activities going on tonight. Actually, you might hear some cheering or chattering outside because we're doing a live event here at the observatory. we're inside my office and we have the windows open so we can hear people outside enjoying looking at the moon and having some food. And we've got a real party going on here. In addition to this virtual event, which we'll be having going on till midnight. And we really want to thank so many people for making this happen. Of course, our viewers, but our donors and members of the Friends of Lowell Observatory, our supporters who help make these virtual programs happen. And in fact, this program we're watching tonight is really being seen by a lot of people. We have a lot of partners who are showing it: Grand Canyon Conservancy, Arizona Science Center, Arizona State University, Astronomy Association of Arizona, NASA, several observatories around Chile, the McDonald Observatory. And I'd like to say a special hello to the Crayford Manor House Astronomical Society, who we worked with through the years. And in fact, one member, Rich Bonner, used to volunteer here at the observatory. And so we're glad to have people from around the world here. We've been trying to will the clouds away, and I think it's working some.
I think we're doing a great job.
Yeah. And in fact, the timing of the eclipse, the moon rose at 7:15, and then the partial eclipse, it actually was partially eclipsed when it started, but we can't really tell that. Maybe you can talk about that a little bit, the penumbral versus the umbral eclipse.
Yeah, so like, when we get into the early stages of the eclipse, we're getting a part of the shadow and part of the Earth, blocking the light. You might have seen some of this in Rezi's video just a moment ago, but yeah, we're not getting a full on at first, but we're drifting slowly into it, where that the sun, the moon, and the Earth are like really lining up, and we start to get that cool red and that cool haze. But at the beginning of the moonrise, we're not getting the full eclipse. We're just getting that kind of like offset partial to the side, but soon.
And we're now at you started seeing a little chigger bite taken out of the moon. That started at 7:27, and when we give times tonight, we're talking about Arizona time, which technically is Mountain Standard Time, but also Pacific Daylight Time. It's a little bit easier to think of it that way. But a few minutes ago, that little chigger bite started happening. So over the next hour or so, we'll see more and more of the moon being covered up, going into Earth's shadow until 8:29, when totality starts. And that's when it's really a cool feel.
Yeah, right now we're seeing, chunks being slowly taken out, and, in old lore, that would have been like the wolf eating the moon, or the panther eating the moon, or the dog eating the moon, or I don't know, something eating the moon. I like that kind of like mythology sort of stuff. I'm just going to show it. I made,
by the end of the night, we'll be eating those.
Yeah, so my dog's here, and so I made her little dog treats that look like the moon. So periodically, she can be the wolf that consumes the moon. I might take some pictures and post them on. I might tag Lowell. But yeah,
I'm thinking I want to try one of those before the night's over.
It's good ingredients.
Hey,
you're welcome to. Flour, peanut butter, whatever.
Yeah, I know all that.
So we do have some questions, and please get in the comments, ask all the questions you can think of, even ask questions you might know the answer to. Ask questions about the moon, about the observatory, about tips for GMing your D&D 5th edition game. We'll answer it. But right now, a common question actually is how does the sun, or how does the moon get so bright? Right? And we know that, the sun's reflecting off the surface of the moon, and that's what we're seeing. We're seeing that illumination. And it looks white because it's it's a diffuse surface, or the surface diffuses the light and kind of spreads it out, because it's all regolith and tiny rocks and things like that. It's actually really dark. The surface of the moon is basaltic and androthitic, and it's really, it's a dark colored surface. It's like the color of asphalt, but the sun is just hitting it so directly. And then the surface is so craggly that it spreads it out and diffuses it. And it can look very, very white, or almost the point of being blue. But soon we're going to get to see the red of the blood moon from the eclipse.
And John, you mentioned something you said is anorthitic. Maybe describe what that mineral is.
Oh, yeah. I brought a rock sample. Anorthite is basically just plagioclase. It's feldspar, right? It's this stuff right here. this is not from the moon. This is from here on Earth. But you know, if you've seen the podcast, you've seen me rant about how the moon used to be part of the Earth. So we share a lot of the same minerals and rock types. So anorthite is just it's got a lot of feldspar, and this type specifically. And that's the light part of the moon that makes up what's called the highlands.
Yeah, so when we look at the moon, we have the basins, the mare, like Mare Tranquillitatis, that to the ancients, they thought they were oceans like we have on Earth. That's why they called them seas and oceans. Yeah. And then you have that lighter area. And when the astronauts went to the moon, 6 missions landed on the moon. And so 12 people walked on the moon, and collecting some of that was prized. And they wanted to get as many different rock types as possible. But, you know, when we think about the geology of the moon, you know, all the astronauts who went there trained here in Flagstaff because these were test pilots. They weren't geologists. And if, you know, if we're going to spend all that money to get to the moon, we better do some science.
Yeah.
Not just plant the flag and thumb our nose at the Russians, because that's why we went.
Well, you got to eat an egg, you get a golf ball. Yeah. What else can you do with it?
That's spaghetti for Alan Bean.
You know?
and so the, you know, Gene Shoemaker was one of the scientists who said, if we're going to go there, we should do geology. If we're going to do that, we have to train them. So Arizona, in northern Arizona especially, was a great place for training, a lot of similar rock types or terrains. And so they all trained here. And in fact, modern day NASA astronauts are still coming to northern Arizona and still going to some of the same places. Jessica Watkins, who just went up to the ISS last week, she's been training in northern Arizona for the last couple of years with other geologists and astronauts. So it's a really neat heritage here to be able to talk about this. And you've got a piece of...
Yeah, so this is what, you know, when Kevin was talking about the Mare, the lunar, this is like basically it's basalt, right? It's a mafic flow. And this is that darker colored stuff that you see kind of filling in these, the cool areas. Right on the surface. That's where we get that.
Just saw another question coming in. What direction was moonrise? And when we're looking at things in the sky, everything seems to rise in the east instead of the west, and that's because of the direction the Earth is spinning. But you also notice if you come back at the same time tomorrow night, the moon won't be up because it's rising 50 some minutes later every night. Because not only is the Earth spinning, but the moon is orbiting around us. So it's rising later every night. So we're at 7:37, and we'll still, you know, Cody told us, Cody, who's the mastermind, Cody Half Moon, who has the perfect name. This is why she was hired here at Lowell, because she's not only outstanding, but she's got a perfect name, and she's the mastermind behind this big celebration. And you know, you know, to be able to talk about the moon all night is pretty neat. She said, well, you know, you guys introduce some things and take some breaks, but I'm not sure if we're going to take that many.
I don't know how many breaks I can take
because there's just so much great stuff to talk about, and we keep looking at the clock. We still have a while till totality starts, 50 minutes or so. But there's, you know, you think about what's happening and how the ancients could see this. You know, and you know, we have telescopes set up tonight. We have the telescope view that hopefully we'll be able to see through the clouds as the night goes on. But you don't need any of that stuff either. This is something that, going back to the beginning of time on Earth, of when humans first looked up and started thinking, they could see eclipses happening. And we could say this is how it'll always be, but actually it won't, will it? If we go thousands of years down the road, there are certain eclipses we won't have anymore.
Yeah.
Why is that?
Well, the moon is slowly moving away from us. The moon leaves us at about the rate that your fingernails grow, and that is slowing down. So eventually it'll be far out there. And you know, especially when you talk about like a solar eclipse, the moon is right now sort of perfectly the size of the sun from our view, right? But you know, back in the day, like 1,000 years ago, 2,000 years ago, 3,000 years ago, I don't know. It was a lot closer. The moon was a lot closer, and you didn't see the same type of eclipse. The solar eclipse looked more like weird rays and sort of diffraction rays coming off. And they think that's where like one of the Egyptian eye symbols came from. Was course, seeing those sort of rays. And over time, the moon's going to get farther and farther and farther away from us, and you'll barely see a dot during a solar eclipse, but you'll be seeing a lot of very, very dark moon during a lunar eclipse like this. One of the questions is why is the moon already red? I thought it turns red once it's completely covered. I think it's red now because it's kind of getting through sort of edge of the air atmosphere, not necessarily from it being eclipsed, but it's the same reason, right? The moon turns red during the eclipse because sunlight is passing through Earth's atmosphere to get to it, right? And so it's the same air that makes a sunset look red, right? So it's the sunlight that's going around the Earth and hitting the moon is only the red stuff.
And that's a good point. If you go on a night where there isn't an eclipse, if you watch the moonrise, or if you see the stars coming up when they're close to the horizon, the moon is often that orangey or red color. But if you wait a few hours, and it's higher in the sky, it's not in general. It's going to be that grayish white. Mm-hmm. That's because the lower to the horizon we look geometrically, the more atmosphere we're looking through. And the atmosphere is like, if you've ever been in the bottom of a swimming pool and you open your eyes, everything's kind of blurry. That's because the water is bending and refracting the light. Our air does the same thing. And that's why observatories are usually located at higher elevations. The higher the elevation, the less atmosphere you have to look through and the less distortion you get. Because if you see stars twinkling on the horizon, imagine what it does when we magnify it. Mm-hmm. It stinks. Astronomers don't, no matter how romantic twinkling stars are, it's not for astronomers because you can't see very well. And I think maybe that's a good time to talk about something else, that's not really an illusion, but there is an illusion with the moon. Quite often, we think about the moon was huge last night. And sometimes it's a little bit closer, sometimes it's further away. But also there's the perception, because when it's low to the ground, when it's rising, there's the land and trees around it. But when it's up higher, there's no framework, it's emptiness. So if you took a dime when the full moon is rising and hold it out and wait a couple hours and hold it up against it, later on you'll see it's actually the same size. It just looks like it's different.
Fun. Your brain actually increases the size of it, right, in your perception. And if you've ever tried to take a picture of the moon with your cell phone camera, the reason why it looks so small on there is because it breaks that illusion that your mind is creating, which is spooky and weird. But yeah, so a lot of the questions right now are related to why is it currently looking red? And that's just because it's still low enough to the horizon that it's there's a lot of atmosphere that's causing it to look red. We're going to get to it being red because of the eclipse about 8:29 our time, and that'll be when totality sort of begins. So that'll be when it's the red from the eclipse, not just from being on the horizon and passing through sort of that sunset or sunrise material. Let's see. A question from the comments: is there a correlation between eclipses and an increase in earthquakes? So I don't believe that there's an increase in earthquakes, right, per se. I know that when you're talking about really fine gravitational measurements in geology, and you can even see it in tidal sort of deposits, but the position of the sun and moon very much can affect the gravity in different ways. So during an eclipse, one way or another, the sun, moon, and Earth are all in alignment, and that can have a noticeable effect on those gravitational measurements. But it's more about I think you see it more in sort of silt deposits and things like that. I don't know if it necessarily has that big of an impact on Earth, but noticeable, measurable, not nothing. Yeah. Let's see. I also wanted to point out Mike's solid Ronnie James Dio reference from earlier. Made me happy. I made a note of that. Yeah. You're talking a little bit about people have been able to see eclipses for a long time, and maybe it's a good time. We've thrown out the terms
solar eclipse and lunar eclipse, and there's also annular eclipse. So maybe we should, because we're going to be talking about this a lot tonight, let's talk about the difference between those. And then we can get back to what you were saying about how the size of the sun and moon appear to be the same, because you could fit, the moon would fit across the United States or so, but we could fit more than a million Earths inside of the sun. So the moon is much smaller than the sun, but it's also 400 times closer to us. So the sun is 400 times bigger, but it's also 400 times further away. So we just happen to live during this time when they appear to be the same. And like you said, when they get closer away we'll talk about solar eclipse in a second, but so let's talk about that first. I'm getting ahead of myself a little because it's so cool.
Yeah. I'm gonna ramble all night. That's what I do. I ramble and I have dumb jokes. That's like
before that, since you mentioned that,
sure.
My favorite moon joke.
Okay.
You know about the restaurant on the moon?
No.
The food is out of this world, but the place has no atmosphere. So with that, let's talk a little bit about the difference between solar eclipses and lunar eclipses, and then we'll throw in annular eclipse also.
Yeah. So you know that from Rezi's video, a lunar eclipse is when Earth's shadow is cast on the moon, right? Because it goes sun, Earth, moon, right? So the sun's shadow goes over the Earth and is now cast on the moon.
And that can only happen during the full moon, when the sun and the moon are on opposite sides. So when the sun is setting, the moon is rising.
Right.
And so you'd think that they would block every time,
right.
But the moon is not in a perfect, it's angled a little bit, and so it's not always lined up, in particular, specifically. So that's the lunar eclipse, and the solar eclipse.
A solar eclipse is basically the opposite. So the moon's shadow is getting cast on the Earth from the sun, which effectively looks like the sun being blocked by the moon, right? And you can almost imagine like that shadow kind of like passing over Texas or wherever, and
in 2024.
In 2024, and blocking out the sun for a bit. And so why it's important that the moon is the size and distance that it is that it kind of perfectly fits over it right now.
So that only happens when the moon is new.
Yeah, it's so creepy.
Yeah, so you have the Earth is lined up, and then the moon and then the sun, and yeah, because it appears the same size, it can block it. But because the moon's distance to Earth changes sometimes a little further, sometimes closer. Sometimes when it's closer, you'd like to have a total solar eclipse because the moon's a little closer, or because it's a little further, it's not covering up the entire sun.
Yeah.
So you have that ring of light around it, an annular eclipse.
So when we talk about like the distance between, or like the distance the moon, because the moon does move away from the Earth, not just this continuous movement, which it does have, but also it's kind of like not a perfect circle around us, right? It kind of drifts in and out between like apogee and perigee. So perigee is when it's closest to the Earth, right? And apogee is kind of when it's furthest from the Earth in its little orbit. Like perigee, like periscope means like around, right? Periscope, like the around scope. So, and then G just comes from Gaia. So it's basically saying around Gaia is the perigee, and then like apostrophe means to turn around, like to turn. And so, apogee means to turn to Earth or back to Earth or whatever. So that's the way I remember it. Yeah.
So there's, and these are all things that people have seen well before we had telescopes. And in fact, they could even predict them once we understood that Earth wasn't the center of everything, that the sun is the center of our solar system, that Earth orbits around that the moon orbits around the Earth as the Earth system is orbiting the sun. It's really basic mathematics. I say basic, but people decades and hundreds of years ago were able to predict these things. And sometimes that could be really handy. In fact, there's a story about Christopher Columbus when he was shipwrecked in Jamaica, and the natives were getting restless because Columbus's men, as the story goes, were not treating them well. And so Columbus looked in his astronomy guide and saw that there was an eclipse coming up. And so he told the natives, if you don't behave, we're going to take the sun away. And lo and behold, he did. And that got the attention of the natives. And they said, okay, we'll behave. And that story was repeated through the years, sometimes in literature, like Mark Twain in A Connecticut Yankee in King Arthur's Court, where he predicts that he's about to die and says, oh, we're going to take you away. And
it's a kid in King Arthur's Court? That's the one I remember.
There's a rabbit, too. I think there was a Bugs Bunny one, too.
Okay.
Somewhere along the way. A Connecticut rabbit in King Arthur's Court, I think.
Yeah.
So something like eclipses, it's not just science, of course, but it's culture and heritage and mythology. And so those sort of things always enter stories that are handed down. It's neat to hear some of those.
We've got another question in the comments before we maybe switch some stuff around. How old is the moon? So scientists believe that this object struck Earth and made one, possibly two moons during sort of the Hadean time period, so maybe like 4.5 billion years ago. It struck and we started to have a moon. So like bits of the Earth kind of came off and were in rings and orbits. At some point, they think we had maybe two of them that had condensed, as the bits moved together in accrete, and then eventually one of them caught up to the other one and smushed in.
And that we say that so matter of factly.
Oh yeah,
we don't know. I mean, we don't know some of the parameters of it, but that seems to be what happened. But really, that's one of the things that came out of Apollo and going to the moon and picking up rocks. Because before then, there were really three main theories about how the moon was formed. Whether it was a piece of rock that Earth's gravity captured, or if it was a piece of Earth that had spun off. So there are different theories. Not until we collected the rocks and brought them back and analyzed the composition and saw that the composition was similar to the upper part of the Earth's crust, could they make that connection. And so, so many things came out of Apollo. I mean, it's interesting, the reasons we went to the moon and what we learned, two different things. I mean, we went for one reason, but the science we learned about the moon, our solar system, our place in it and such, there's really a lot. And we'll talk about more of that. As you were saying, John, we're gonna switch programming here. We're gonna be cutting out for a few minutes to talk to some other folks, but we're gonna play a program about the surface of the moon. So we'll play that video. We'll show some live views of the moon. You can take a break from listening to us for a little bit, and then we'll be back in a little while.
Get those good comments in.
Hi, how's everyone doing? My name is Juan Alberto Ruiz and I'm an educator here at Lowell Observatory. And I'm going to talk to you about lunar features today. So the way we have observed the moon has changed drastically throughout human history. Whenever you look up and see a full moon with your naked eye, you can clearly see lighter and darker patches across the surface. Cultures from all across the globe have seen things across these contrasting surfaces like a man or a face or even a bunny. But the lighter patches are what we refer to as the lunar highlands. This is where you tend to see the most craters. The crust is the thickest in these areas and tends to be older than the darker patches. The far side of the moon is covered with craters in the areas we also refer to as highlands. The biggest moon's craters can be found on the far side. It is known as the Icon Basin with a diameter of 2,500 kilometers and a depth of 12 kilometers. The dark patches are known as the mare, and that is Latin for sea because at one point in human history, we actually thought the moon was filled with liquid water. We now know that mare are some flatter, smoother areas on the moon, and it's filled with a lot of basalt. Now, we think that this area on the moon is a lot thinner compared to the crust on the highlands. So we believe that these giant impacts from meteors and comets actually broke through the crust into the mantle, and all that molten rock, the magma, actually erupted towards the surface and completely filled the near side of the moon with magma, which eventually cooled off and left us this flat, darker areas that we refer to as the mare. These areas are younger than the highlands, and that is why we tend to see less craters. Remember, the moon also does not have a magnetic field or an atmosphere. So these areas are also younger because we believe that they have not been exposed to the sun as long, so they are not as sun bleached compared to the highlands. Some of the easiest features to see on the moon are the Tycho, Copernicus, and Kepler craters. You also want to look out for those notable mare like the Sea of Tranquility where the Apollo 11 mission landed, and others like the Sea of Crisis or the giant ocean storms. The moon also has valleys and mountains very similar to those what we have here on Earth, but the thing is that the moon does not have plate tectonics. We believe that these mountains were formed from these giant impacts that actually lifted up the crust towards the surface and gave us these huge mountain ranges. The most notable mountain range is the Apennines Mountains, where you can find the largest lunar mountain known as Mons Huygens. And this is a giant mountain standing at around 18,000 feet or around 5,500 meters. These mountain ranges can be found separating the Sea of Showers and the Sea of Serenity. The moon even has some weirder features like these lunar swirls that look like paintings all across the surface of the moon. One of them is an anomaly that we refer to as Rainer Gamma. And these are just few of the very prominent lunar features that you can see with your naked eye and through the telescope. Our understanding of these features will only continue to progress as we continue to study our closest companion and one day return to its surface. I want to say thank you to all the members and donors that support Lowell Observatory and make all of this possible.
don't know what else to do. You can't hear us? Good? Okay.
Hey, we fixed it.
Well, technical thing, but we're really excited because if you look, the clouds have cleared up. We've got a great view. You can see the real bright part is the part that's going to be covered up over the next 6 or 7 minutes. And so we're getting really close to totality. So let's talk a little bit about what's happening. We're starting to get it looks a little pinkish, but it's going to get even more red once that little sliver covers up. So John, let's talk a little bit about why the color is going to be changing.
Yeah. So you know, if you look at the moon there, wherever it is, in the view, you can see that there's the bright full sunlight portion, and then you can see this red shade, this that's sort of being cast over it, right? And that's going to get more and more dramatic as it goes. Once we hit full totality, it'll be like beautiful. But it's because it's the same reason sunsets are red, right? It's the atmosphere of the Earth is sort of scattering those blue wavelengths and the green wavelengths and the things towards ultraviolet away. And what's left is the red, and it's greatly scattering. So we're only getting basically sunset and sunrise light hitting the moon, right? Because of the light kind of passing around. Now, once it's in totality, that's all there's going to be hitting it. So it's going to be very, very dramatic. Right now, it looks a little bit pink, and outside you might be able to notice a little bit of a tint as well. But when we hit totality, it's like it's all that orange and red light hitting it 100%, and that's when you really get to see the noticeable difference.
And we had a question about how frequent we have eclipses. You know, we have both the solar eclipses and lunar eclipses. Lunar eclipses, you can have 1 to 3 a year or so. In fact, we had one that was visible from the Americas last November, but it was really late. Mm-hmm. And then the next one, we have one November 8th. That'll be visible from Asia, Australia, Americas. And so they're a lot more common to see than, even though solar eclipses you can have more, they're very restricted to where you can see them. Lunar eclipses you can see from a wide area. And so this is just a great opportunity. We're just, 4 minutes from totality, and you can see how it'll appear to darken or even brighten as it gets closer. Part of that is exposures, part of that is the light itself. There's a lot of different factors that go into it. But the good thing about this is, with a total solar eclipse, totality is up to 5-6 minutes, something like that. With this, we have well more than an hour. And you can see what's happening now. The camera is, the exposure it's easy to underexpose or overexpose, so it's compensating with that little red stripe. But in just a few minutes, we'll be done. It'll be completely covered.
Yeah, it's currently losing its mind trying to keep up with the eclipse. Yeah. So again, if you've not seen the Earth's shadow being cast, there's a great view of it right now. Little shadow puppets coming from the Earth. So like stick your hands out to the edges and make like a bird or a wolf or something, and maybe you can see it up there.
And we've been throughout the night. We've had clouds, but thanks to our friends at Lowell Observatory, we've been able to tune into their view, which has been spectacular. Our clouds have moved away, so we're really excited to be able to see it here. We've also been talking with folks in South America and across the world and sharing different views. So it'll be interesting if you can easily get on the internet. You can get live views in a lot of places to compare and see the differences. Right now, I'm just thrilled because the forecast was pretty lousy. With the moon, even eclipse,
beautiful.
You can see it some, but right now it's just cleared up so well.
And you can really see the Mar popping out and the crater, that crater down there, with that really, really beautiful ejecta pattern. Gorgeous, beautiful little crater.
And as we're looking from our view, there's that circular crater toward the top. That's Mare Crisium, the Sea of Crises. And then below that, it looks like there are three kind of irregular circular areas, mare. The middle one is the Sea of Tranquility. And toward the bottom of that is where the Apollo astronauts first set foot on the moon in 1969.
Speaking of the Apollo astronauts, so I have written some terrible jokes specifically for this. Hopefully they're deep dives and groaners.
Now, are you apologizing ahead of time?
Ah, you got me. What was Michael Collins' favorite song?
What's that?
Dark Side of the Moon. No explanation. Google it.
Wait a minute. When was that written, actually? I'm wondering if that became his favorite afterwards.
Maybe.
Do you know how the moon cuts his hair? Eclipse it.
Snaps. Why is the late Heavy Bombardment's Spotify such a bop?
Why?
It's got all the greatest classic rock hits.
And with just a minute toward totality, we lost the audience on that.
Probably, hopefully.
Gosh, look at that view.
It's gorgeous.
And it'll be interesting to see once it is in complete eclipse. And we should talk about also that when it's eclipse, when it's in totality, where it'll start coming out in an hour plus. It'll be on the other side. But we're real close, and you can see that it's still lit up a bit. We have some clouds that are moving across there a little bit.
Makes it extra spooky.
And then the camera trying to compensate. So we're pretty much at totality, and now the camera is just adjusting the light. And then it'll be interesting to see if we get, if that gets a deeper red, or if it stays similar to what it is. Like from my angle, it still looks a little pinkish.
Mm-hmm. So we're crossing through that.
And you think about throughout time, you think about connecting to generations of people, our parents and grandparents, and going back generations, they could do just what we're doing, looking at the eclipse, and the same thing, just in awe of what's happening to them. They, going back a ways, they didn't know what was happening, and an eclipse moon was some portent of doom.
Right.
So you imagine, maybe you have a story or two, but what, we're looking at this and we understand the geometry of the sun and the moon and earth. I mean, what's happening, but to the ancients, this was trouble.
I mean, for a lunar eclipse like this, like you see the moon and it looks great. It's a full moon, it's bright. And then it starts disappearing for no reason. That you don't see something approaching it. Right? It just looks like the sky itself is enveloping parts of the moon. That's crazy. So in Norse mythology, that was like a wolf eating the moon, right? And Ragnarok was foretold by a wolf eating the moon and another eating the sun, which would have been a solar eclipse. But they didn't know that you can't get that at the same time. But it just happens out of nowhere. The sun's way behind us.
And it's interesting because we're now getting eclipsed by the clouds,
Mm-hmm.
but they held off until we went into totality. And we'll just, we're going to be in totality for a while. And so we've got more than an hour. So we'll just see what happens with the clouds. But it really adds some mystique to it because it's both totally eclipsed and the clouds. You expect Wolfman to be running out of the woods anytime here.
It's double. What?
Yeah.
We're being occulted by the shadows and the clouds.
And something we didn't mention yet before is when we were you could see just that little sliver left. It wasn't as the moon was darkening. It's not a straight line. It's curved. And to the ancients who started understanding what was happening, they realized that that proves that Earth is round and not flat. If it was flat, it would be a straight line.
Mm-hmm.
And so even from that, without any special equipment. These people were smart. They started figuring out what was happening, and do some science with it. And I think that's the neat thing with families. Like you take your kids out to see this or look at a video, and you know, you can do some science just by looking at without anything else, anything special.
Yeah. Let's see if we've got any quick questions while we're.
Do you remember your first total lunar eclipse, John?
No, probably here.
Yeah, mine was here.
Yeah.
I mean, we, you know, growing up, we certainly had them, but I grew up in Ohio, and I think it was always cloudy. It seemed like.
Yeah.
I don't know if we ever saw the sun. It got warm.
Florida and
Yeah.
England, like, it's always kind of something out.
Yeah, I grew up collecting fossils, so I was always looking down. And now at the observatory, we look up, and it's fun to be able to see this. The one, like we said last year, was just at 2, 3 in the morning, and you know, it's fun to get up and see it. But this is, you know, for us in the West, this is about as well positioned and timed as we could get. You know, I mean, for some people it's getting late, but it's an opportunity. It looks like we're back on our view from our friends at McDonald Observatory in Texas. And if you get a chance to visit McDonald, you know, there's a lot of similarities with us. We have passionate people doing astronomy for a long time, a great education program. Of course, if you listen to NPR or other stations, you're familiar with Stardate, and that comes out of McDonald Observatory. And so this is what's great about having collaborations is as we have some clouds moving over, we can look at the view in Texas.
A couple fun questions from the chat. Someone had asked, you know, if we can see this from every part of the world. So if you can see the moon, you can see this, right? It's not like a solar eclipse, which you really need that perfect timing to be in that perfect solar shadow. We're casting a shadow on the wall, right? And so you can see that shadow on the wall from anywhere you stand. But during a solar eclipse, it's, you know, someone covering a lamp with a tiny little sign, right? If you move around, you can see the sun again. So we can see this type of eclipse from anywhere that you can see the moon.
Right now. So if you can see the moon right now, it's eclipsed.
Yep.
And, you know, you think also when we look at this, we're so Earth-centered, and that goes back, you know, early days when, you know, the idea of how many planets are there. Well, at one time, the sun and the moon were considered planets. Earth was at the center of everything. And then we got to learn more and realize the Earth wasn't at the center. But another way to think about that also with eclipses, we're thinking about this, our view from the Earth. But there are eclipses on other planets. You think about the gas giants, way out there are eclipses because the sun is just a point of light. And so if you were on Jupiter from some of their larger moons, the sun is going to be easily eclipsed. So there, you know, we think about our perspective here on Earth, but, you know, what if we were on the moon right now? What would we be seeing?
That's a question in the chat.
Yeah.
Thanks to y'all. We would be seeing a solar eclipse. It probably wouldn't look as great because the Earth is huge in comparison.
As seen from the moon. Yeah, it's just, you know, it's always good to put yourself in other people's shoes. Mm-hmm. So for those on the moon, that's what they would be seeing.
Yeah. A beautiful solar eclipse with probably some fun red tints around the edges and things like that. Like with a solar eclipse, we see helium right around the edges of the moon, right? So the light shining through, we can kind of block out areas of the sun's brightness, and that's how you get. So helium was named Helios, right? But with an eclipse, if you were on the moon looking at a solar eclipse with the Earth blocking it, I bet you'd be able to see interesting things with Earth's atmosphere. It would look really neat. Yeah. So another great question in the chat was, is it true that we're seeing the past moon? Yeah, about 1.25 seconds in the past, right? That's just, light takes time to go to places. It's about 8 light minutes away from the sun is Earth, about 1.25 light seconds away from the moon. So,
and that was important during the Apollo missions. When they're communicating, there's a slight delay, a half second or whatever delay for the radio signals to get here. But as you say, like with the sun, it takes 8 minutes for sunlight to get to us.
mm-hmm.
You think about planets like Jupiter and Saturn, it's 30 minutes, 50 minutes. When you're looking at them, whether it's a point of light with your naked eye or through a telescope, you're looking back in time. And that's one of the neat things when you think about astronomy. We're studying old light. It's taken that long to get to us. Mm-hmm. It's kind of like we're archaeologists of the sky, because we're, in theory, the sun could blow up and we wouldn't know it for 8 minutes.
Yeah.
Although we know enough about the sun to know.
See that it's happening.
Yeah.
It's the moon is 1.25 seconds. It would take like 1.25 seconds to get to us, but it's still really far away, right? So it's 250,000 miles away, right? It's really far. That's like how far a Jeep can drive in its total lifetime. That's so for other people, maybe like a whole bunch of kilometers. So I've taken this down. It's the distance is 214 million Colin Firths across to get to the moon, which translates to 236 million Tom Cruises.
Well,
it's really far away.
That was 236. Okay, I just
so 236 million Tom Cruises to the moon, and 214 million Colin Firths.
And this reminds me of our scale models here at the observatory, because we start talking about distances. We can visualize what a foot is, or even a mile. We have kind of a feel, but millions of miles, what's that mean? Or billions of miles. And so it's easy to set up a scale model. Like we have one here at the observatory, an inch equals 1 million miles. And on that scale, Earth is, I can spread my arms out, and that's about how far away Earth is. Pluto is about 100 yards down the sidewalk. The next closest star to us, Proxima Centauri, would be in Los Angeles. And so that's why these scale models are really useful to kind of get an idea of just how far things are, because a light year, a million miles, it just, we don't work in that kind of time scale, or distance scale, I should say. Let's take a look at the view also.
They're still getting the one from West Texas.
Okay, and you can definitely see it. It's kind of got an orange hue to it. Again, because of the light is still being refracted through Earth's atmosphere. And we look out the window, but it's dark. I can't tell if it's cloudy or not here. I can hear a lot of people having a good time outside. So our on-site program seems to be going really well. And, this is what's, you make lemonade out of lemons. COVID was so challenging, and still is. It's not like we're done with it. But one of the things at the observatory that we're able to do is, our educators, usually are spending time with visitors and doing programs. And we always had this, in recent years, this idea of doing virtual programs where we could reach people around the world. But where's the time to do that? Well, during COVID, our leadership committed that nobody would be laid off. Everybody will still be paid, which took a lot of hard work. But it meant that educators, they're not working for the public right now, we're closed. It gave them time to develop the ability to do these programs. Danielle Adams, who led this charge with our team of educators, and now we're able to produce these programs. And for eclipses, for meteor showers, name it, we can do these things fairly easily now. And we have our behind the scenes crew who's making this all happen. Cody Halfmoon, who has masterminded this, Heather Craig, Alex Elbert, Madison Mooney, and I'm forgetting some folks, but we've got our entire marketing team, our education team, we've got astronomers up here at the observatory. And then again, as we mentioned earlier, the reason we're able to do this is because one, Percival Lowell, our founder, said, I want to do science but what's the point of doing science if you don't share it with people and excite people about the universe? And so that's part of what we do. And we're able to make this happen because of donors, our friends of Lowell Observatory. And we have all sorts of partners tonight in not just on site providing food and drinks and everything, but we have partners around the world, the Grand Canyon Conservancy, Arizona Science Center, ASU, Astronomy Association of Arizona, NASA, several observatories in Chile, McDonald Observatory, we've been looking at their feed. We know that Reuters news agency is providing this feed. It's great to have this global interest in such an event and to be able to not only have the interest, but to be able to share it. And so when our view, we have some clouds, we can click over to our friends at McDonald and they're able to, have a view. So it looks like we're back on our view, is that right?
Yeah.
And just before that bunch of clouds moved, you could really see more reddish hues. And so it's neat to be able to see that color of it and that eeriness. And again, the clouds just add to the spookiness, and you can see why ancients, before we knew better, really were superstitious about what was happening. Just like meteors falling from the sky is falling. Something bad was happening, they thought.
I think we're going to take a little break and leave you all with a view of the moon until our next kind of segment starts. We'll let you take a break from our jokes, and then we'll get to the rest of the questions the next time we're back on.
Well, I think we should leave off with a joke or two.
Oh yeah, sure.
So that they really appreciate the joke or having the break. Let's see. What did the therapist say to the moon? Don't worry, you're just going through a phase.
Boo. Okay, one last one for me then. Why does the Lunar Command Module love ska music so much?
Why is that?
Because when it gets to the lunar module, it wants to pick it up, pick it up, pick it up. Okay, that's all. That's what I got.
With that, there's probably a cheer going up in the ether world. We'll take a break, and we'll just have our views of the moon, and we'll be back in probably 10 or 15 minutes, and we'll have some more programming, talk a little bit more about the eclipse, look at some views, and just keep enjoying the evening.
Hi, I'm Dylan, an educator. Have you ever heard of a supermoon before? I'm going to talk a little bit about the moon's orbit and how it explains where this idea of a supermoon comes from. So what keeps us here on the Earth and the moon orbiting around it is gravity. The mass of the Earth warps space-time, kind of like a heavy bowling ball on a trampoline. And so this causes what we perceive as the force of gravity, drawing things towards it and allowing for orbits around it. The moon takes about 27.3 days to go around the Earth once, and this is known as the moon's sidereal period. It takes a little bit longer to go from full moon to full moon because the Earth is also moving around the sun, and so that comes in at just under a month at 29.5 days. The moon, as with most things in the universe, doesn't orbit in a perfect circle, rather it orbits in an ellipse. So this means at one point in the moon's orbit, it's a little bit closer to the Earth, and at one point it's a little bit further away. At its furthest, the moon is about 253,000 miles from the Earth. This is known as apogee. And at its closest, the moon is about 226,000 miles away from the Earth. And that is known as perigee. So to put this into perspective, the moon on average is about 3 billion cans of beans from the Earth, but its distance varies by about 400 million cans of beans. And this animation shows that change in distance. It's also worth mentioning that all this is happening at a slight tilt. Sometimes the moon will be a little bit above or below how the Earth orbits around the sun. That's actually why we don't have eclipses more often. So let's get this back to supermoons. Now, what causes a supermoon is when the full moon matches up with when the moon is at perigee, when it's at its near point. Because it's a little bit closer, it can appear slightly larger in the sky and also brighter, but despite its name being supermoon, the difference between a supermoon and any other full moon isn't always all that obvious. So let's say we wanted to see the moon as large and as bright as we possibly could. Well, there's a couple things that you could do. For one thing, the way that we see the moon in the sky actually changes depending on where you are on the Earth. Now, here's a picture of a supermoon when it's near the horizon and also when it's high up in the sky. And because of the Earth's rotation, bringing the second image a few thousand miles closer to the moon, it actually appears slightly larger. Another thing you could do is be near the equator, and the Earth isn't actually a perfect sphere. It actually bulges out near the equator, which would bring you slightly closer to the moon, further from the center of the Earth. Alright, so now you know what a supermoon is, how to get the most out of one, and a little bit more about the moon's orbit. And I just want to say thank you to our members and donors for making all this possible.
enough time because totality is going to start ending. I forgot the time. 9:53. We still have some time. So you went outside to take a look at it?
Yeah.
I went outside and I couldn't even tell where the moon was supposed to be. But then right before coming in, we could see it.
Little pop. It was nice.
Yeah. And so we still have half an hour or so of totality. We're seeing gosh, it's really opened up again, the clouds.
Yeah, it's nice.
That's nice to see. And something you will see when we were looking at this, the view to the top right. So the shadow was moving from the lower left to the top right, and it'll continue in that direction. So when totality ends, we'll start seeing the lower left, it'll light up and go to the upper right, just like it's been doing. So who do we have over here?
Oh, that's my mom. That's Ember.
I think you had something to give her.
Yeah, I've been giving her these little wolf cookies. I've been calling them wolf treats. They're like little dog treats I made that look kind of like the moon on some of them. But I posted a picture on the Lowell. I don't know if you could. There's a little wolf consume the moon. Oh, yeah. Fruit bite. Anyway.
Yeah, it's like a lot of visitors that come up here, we talk about astronomy or look through telescopes and the squirrel goes by.
Yeah.
The ever squirrel with big fluffy tail and big ears, and suddenly what? It's stars? Well, yeah.
We're on a huge nature sort of preserve up here with all of what's it called? Mesa Hill or whatever. What's
Mars Hill or Observatory Mesa.
Observatory Mesa.
Yeah.
So we get a lot of wild animals, deer and elk and all the squirrels and things, and coyotes and
we just this year we've seen a couple javelina,
yeah.
which I've never seen up there before. And so when it's dry in the past, every once in a while we'll see a bear, a little black bear. But it's really it's almost like a nature preserve up here.
Mm-hmm.
And it's such a fun place to learn and share stuff with the family. And the moon, the eclipse is being eclipsed again by the clouds. It looks like. But it's nice because we've been able to get some views of it at least. And I'm looking forward to when it starts coming out, because then again we can see that not the straight line of light, but the curved line.
Real curved chomp mark.
Yeah. Well, let's look. Do we have any questions in there?
Yeah, let's take a peek.
And while you're looking for questions, I just want to thank again, especially McDowell Observatory. They've had some great views tonight, and especially as we've been clouded out, we've been able to show theirs, and they've shared views that we've had. Also, the Grand Canyon Conservancy, Arizona Science Center, Arizona State University, Astronomy Association of Arizona, NASA, several observatories around Chile, and the Crayford Manor House Astronomical Society in England. Several of their members were joining us tonight. Hopefully everybody's been able to see a good view, whether it's from ours when it's been opened up or some other places that we've been able to feed into.
So going through some of the questions that we might have missed and or from before. Hey, what's that white pixel in the bottom? Several people have asked that. That's a star. I don't remember which one. It's got a weird name. Haley, I know, posted it in the comments. She's got like a blue link on her name in the feed. It's like Zebra, Zebuchadnezzar, I don't remember. But yeah, it's a star. So is it a planet because it's not twinkling? No, stars twinkle because they're a point source when there's less than stellar seeing. So the wind or atmosphere kind of disrupts them. But because it's like a point source, it's one pixel, so it's easy to blur it. Versus a planet, doesn't twinkle because it resolves as a plane of light coming in. And so like if a little bit of it gets wiggly, you still see it. But if seeing's good, you don't get any twinkle. Are they seeing anything from the space station? I don't know where the ISS is right now. It whips around the Earth.
Every 90 minutes.
Yeah. So when they're on this side, you'll see a cool blood moon. The super super flower blood moon, I think. That's what the
something like that. So
yeah.
Flower, yeah, the Farmer's Almanac really popularized those general names based on ancient and native nicknames. And so for the one for May, although every culture calls it something else, but for May they call it the flower moon. And if you talk to some of our astronomers, they kind of laugh because that's not, they don't think of it in terms of like culture, it's the science behind it.
Yeah. Yeah, and when we talk about the supermoon, we just mean that it's at perigee, so it's very close to us.
And we were talking before about how big the moon can look, especially when it's rising, because that perception, it looks like it's bigger. But yeah, sometimes it's closer, sometimes further away. And it's funny how you can observe a lot of this stuff if you think about it, it makes sense how things are moving in the orbit. And you can get some balls and demonstrate all this. I think, it's fun to get, like with kids, you have one holding a flashlight, is the sun, the earth, and the moon, and have them orbit around each other. And it's really easy to show how phases happen, but also how eclipses happen.
Yeah. I've seen kids do the eclipse dance at youth, because I used to work at like STEM youth camps and stuff, and it's always really funny. Like one of them got a flashlight and they do like this dance to show.
You have any steps you can demonstrate?
Oh, they just sort of move around. They're real young. They're just sort of like jumping.
So it's like kids learning how to play soccer. It's like this amoeba of kids moving around in mass with.
Well, it's like three kids doing like a weird figure 8 around each other.
Oh, that's pretty good.
And then they're showing like, now I'm in the shadow. Like, you're the eclipse. Let's see, another question. The view looks a little bit different from West Texas, especially coloration. Is it the difference in the telescopes? It's probably a difference in the telescopes and the imaging software that we're using, but also, different altitudes, different clouds, different amounts of atmosphere can kind of also affect the coloration. But it's probably due to whatever imaging software we're each individually using. And
trying to adjust to the light levels, especially when it comes out of totality, you start getting a little bit of brightness, then more and more. It really makes it funky for the cameras to get a good image. It's going to keep changing, just like with our cell phone. If you point it in a bright source, it's going to it's going to be whited out and then it will adjust.
Who knows what? Yeah. Let's see some other fun questions. Why is the moon visible now when there's supposed to be a total eclipse? I suppose this question was from when we were in like full totality. The reason is because a solar eclipse is the one where it like blocks out the whole sun. A lunar eclipse is an eclipse in that it's still a shadow being cast, but it's there's still quite a bit of light making it around the Earth, right? Making it from the edges of the Earth in to still illuminate it. So it's because it's a shadow and not something in front of the light source, right?
Yeah, it's not the direct light, but the atmosphere of Earth light is still bending around that. Yeah. And that's why the color also.
Yeah, it's the equivalent. A solar eclipse is like putting a cover on the light source. And then a lunar eclipse is like kind of being in front of the light source while your shadow's on the wall still. You can still see the details and stuff in your shadow, right?
And this is an interesting question that was here about wondering if a lunar eclipse can cause lightning. And, that's interesting because all that's happening is the Earth is blocking the sunlight from hitting the moon. And so there's no atmospheric thing on Earth happening. But during a solar eclipse, when the sunlight's being blocked, the temperature can really drop.
Yeah,
and the crickets come out, they think it's night animal. And sometimes you can get moisture. You can even have to cloud up because it cooled down so fast. But so with the solar eclipse, when that sunlight is blocked from us, and it's kind of like it's cooling down at the end of the day, you can have some weather changes, but not with a lunar eclipse.
Yeah, lunar eclipse is same old day on Earth. It's just crazy for the moon. And if there was lightning on the moon, maybe, but there isn't.
Because
there's no atmosphere. Yeah. Really, really terrible atmosphere. Other questions. Ruth, Yes, my dog's name is Ember. She had a foster mate named Ash, so we named them Ash and Ember, like the campfires here up in Flagstaff. Yeah, she's sweet. She's a little goblin. Let's see. Would you please name the 2 stars that were occulted?
Yeah, I don't know. Well, we'll have to check with the educators on that.
Yeah, I could pull up Stellarium. And then someone else was asking about the stars, but I don't know their names offhand, but I'll pull it up.
And that's something tonight. We've had this live feed. When John and I took a little break earlier just to try to enjoy some views of the eclipse for the viewers, and we went outside, and it was so neat because there was a food truck here earlier. There's music playing. There was a juggler with lit, illuminated, whatever those things are. And it was really a fun, festive atmosphere. And so while it's nice to be able to watch this virtually, especially if you can't get here, if you can get to Flagstaff, it's such a great experience to come up to the observatory, day or night. We're open pretty much every day, and except for major holidays, and every night but Tuesdays. And there's always a lot of things going on. And tonight we have this great eclipse, but other nights we don't have that. But be able to look through telescopes and be around people that are really passionate about it and can tell you about what you're looking at. And I think one of the important things about Lowell is, we have some of the smartest people around, our scientists, and yet, our scientists are also so easy to talk with and work with, and they want to share their excitement. So, we have programs like Ask an Astronomer, where one of our astronomers is on hand, not to, boast about how smart they are, but to try to share the excitement. That's what we're all here for, is sharing enthusiasm. And podcasts like this, or live streams like this, is one kind of program we do, but we also, Cody Half Moon, who's spearheaded this effort tonight, also started a podcast series, Star Stuff. And this is, we do, one a week or so. And it's great because you can watch it live, and you can interact and send in questions, but then you can watch it afterwards also. And we cover so many topics of science and, but other things also, like history and mythology and culture that tie in with astronomy and science. So there's a lot of different ways of interacting. If you can get up here, great. If not, you can still interact with the observatory.
Yeah, we also do interactive stargazing. I think certain Tuesdays, the first Tuesday of every month.
Something like that.
Really cool. Or we have a camera on the telescope and we can talk about what we're seeing and view it live.
And one of the other things that's neat is, we've been talking about our view tonight from the Giovale Open Deck Observatory. That's shown somewhere on the little tagline. And that's from one of the telescopes up there, a 5.5-inch refractor. This facility is so neat. We opened it in the fall of 2019, and it's a building. It kind of looks like a hangar. The whole building rolls back, and you have 6 telescopes that can look at different things in the sky. And this is kind of phase 1 of our expansion, because our attendance has really been growing over recent years. And we want to accommodate folks who want to come here, as well as give them state-of-the-art experiences. And so in 2024, in just 2 years, we're going to have a brand new visitor facility. The Ethel and Kemper and Ethel Marley Foundation Astronomy Discovery Center is still a bit of a tongue twister, but that opens in 2024, and it's going to allow us to do even more programming, and the experiences are going to be great. The state-of-the-art theater, this wraparound theater, a rooftop observing plaza. We thought about getting a planetarium. We got the real thing. We have dark skies and heated seats because it gets chilly. And so it's just fabulous what's happened with the observatory here. And it looks like the clouds are there, but we're sort of able to see it. As I say that, it's darkening.
And we do have the McDonald view that we're kind of switching between. I did find the answer to the question. Yeah, it looks like some of those are HIP 76106 is the name of the star. The other one is HIP 76033. I think those are the ones that you guys are questioning. They should be the brighter ones in Libra.
And that's something interesting with, I mean, we have clouds here right now, but during a lunar eclipse, you can still see the moon. But it's darkening enough to where you can see surrounding stuff a little bit better. And so some stars that kind of stand out a little bit more. We don't really have any planets in the night sky, naked eye planets in the night sky right now.
You can see Earth pretty well.
Yeah.
That's my
That's not clouded out. Yeah, you can't look up, but you have to look down. But it's it's fun to be able to share this stuff. And like we were talking about earlier, we think about our Earth center view, but if we were on the moon, we would be seeing the sun eclipsed. And you can go on other planets have eclipses also. And so it's just like other planets have lightning. Jupiter has magnificent lightning because all these clouds, the layers of clouds. And so when we think about what it's like here, we can project that other places. Mercury and Venus, they don't have eclipses because they don't have moons. But the other planets, the rest of the planets have moons. So there's a lot of different ways of looking at space. We just see it from one perspective. How are we doing on questions? Any others that
I don't see any more
ones that we didn't have coming in yet?
But let me fun questions, nerds. Yeah, so if I've been on the Star Stuff Space Podity. So far, not a ton of questions. I would say get at me in the comments, ask me all the questions, correct me for all the wrong things I say, like incorrect stuff. But yeah, I'd love to hear what y'all are curious about.
And also we can talk again about the frequency of these eclipses. We talked a little bit before about the total solar eclipse that's on April 8th, 2024. And that's going to be visible from a wide swath in the United States, from Texas, kind of in the northeast trending line. It'll go through my hometown, Valley City, Ohio, and continue into Canada. We don't see that many total solar eclipses in the same place. Like on average, it's several hundred years until you see another one in the same location. But lunar eclipses, total lunar eclipses, we had one last November, that was visible from Flagstaff, except it was real late. There's another one this November, another total lunar eclipse that'll be visible from the Americas. I don't know exactly which parts, but it'll be widespread. And so total solar eclipses, the place that you can view them from is just a lot more restricted than lunar eclipses. A few years ago, we have a cabin up in Four Corners area, and we drove the ATVs out and climbed this hill, Turkey Hill, and watched a lunar eclipse from up there.
Oh, cool.
It was a great setting. And in the middle of, the only noise we heard were some cows that were doing their thing, but otherwise it was, in the middle of nowhere. And you really feel connected with the universe.
Yeah, let's see. Could we share a little bit about what our first experience of a solar/lunar eclipse was like? I've never seen a solar eclipse, not a full one. I've seen the partial one up here back 4 years ago, 5 years ago, I don't remember, a bit ago. And then my first lunar eclipse, I guess, was also here, but I was also on a live stream, so I didn't get to see it.
I don't remember my first total lunar eclipse. It was here at Lowell. I just don't remember growing up in Ohio, going out and seeing one. It was probably cloudy. But I don't remember my first one. It was in the 90s. It was around the time, I seem to remember we had one near when Hale-Bopp was in the sky. But my total solar, the only one I've seen, I've seen partial. I think partial solar eclipses are so cool because you can go outside underneath trees and the sunlight coming through, you can see all these mini eclipses.
Yeah.
Or you can get a cheese grater and the light going through there. There's a lot of ways you can observe it. But totality, and so I think it's cool to see partial solar, but totality of the sun it's almost life altering. It's not just visual, it's a feel. And the temperature cooling down and the eeriness of it. When I saw it, Lowell Observatory hosted an event in Madras, Oregon. This was the 2017 one. And the weather worked out nicely. We were inside the high school football stadium. And so we had a countdown on the football clock. And Science Channel was broadcasting it. And I was there with my wife and some other family, and of course the Lowell team and visitors. And if you get a chance to do it, like you'll probably be in Texas, because the observatory, we're co-hosting an event at Baylor University in Waco, April 8th, 2024. And that's going to be a great opportunity. And the reason we chose that site is because, you want to have a place that has historically decent weather, and that's pretty good there. My hometown in Ohio, in April, it could be snowing or raining or whatever, but Texas is pretty good at that time of year. So it's a great opportunity to see solar eclipse. And even though the lunar eclipse is more common, it's still cool to see it, especially because you don't need anything special. It's fun to look through a telescope, but mostly you just, I was looking on social media earlier, and everybody's posting pictures. It's just really neat to be able to share it.
I'm really excited to see the one in 2024.
Yeah, and it looks like our feed's back on McDonald because I think we're pretty thick on clouds again.
Yeah, we got some fun questions, so let's see.
Yeah.
Do you know the exact date for the 2024 solar eclipse?
April 8th. And I have the time, I can't remember it offhand. Oh, we're back to Lowell views, it sounds like.
Oh, cool.
Let's take a look there.
Oh, well, we're sort of off on the left right now.
Okay.
But like, at least the lag is cool.
And we're 9:53 totality end, so less than 10 minutes. And we'll be able to start seeing, if we can have a good view, we can start seeing a little chigger bite that starts getting brighter. And then the images will start getting real dark and then real light as the cameras try to adjust. And it's fun to see totality, but then it's also fun to see it come out because you can see what's happening. You can see the shape of Earth, that rounded shape as we start coming out of its shadow. If we're able to do that with the clouds, this is astronomy, where there's so much we get excited about and then hope for the clouds. And tonight it's worked out. It has been crystal clear, not close to that, but we've been able to really get some good views. And even with the clouds, you can see some of the mare and the darker areas. You wonder, as we go back to the moon, hopefully that's going to be happening soon with Artemis, but it would be interesting to have a mission with astronauts there during an eclipse to get images to be able to view it from there. And it's not going to be clouded out because there's no atmosphere, there's no clouds on the moon. And so they don't have to worry about this at all.
Yeah, that would look pretty stunning. Let's see. A couple other quick questions. Is there a latitude and longitude that is best to see the most eclipses? For solar, I don't think so.
I don't think so. It changes. Like we had the one that went across the United States in 2017, and I think there was a place. I could be wrong, but it seems like maybe in Kansas or Missouri that they saw totality there, and they'll see the one in 2024. But statistically, it's several hundred years between a total solar eclipse being seen in the same spot. It's just not that frequent. So they happen several times a year, but the place that you can see it from is a lot more restricted. And there's one coming up in several years. We've seen ads for that you can see in Egypt. And so you can take a cruise down the Nile. Down the Nile is going north. And, you know, even if it's clouds out, you can still see the pyramids and everything like that. That's the way to do, I think, an eclipse cruise, total eclipse cruise.
Yeah, that sounds real cool.
Those are cool.
Yeah.
If it's eclipse, you know, if it's cloudy, you can still see it.
And I guess a lunar eclipse, the equator. I don't know.
Yeah.
Where do you see the moon most often? Yeah, probably around there, somewhere between the what do you call them, like the horse latitudes or whatever. Let's see.
And we just before you go to that question, we've got about 10 minutes left before we end our programming. We're still gonna are talking. We're gonna step away, but we'll still have views for the next 2 hours after that. So we got about 10 minutes left. So if you have any more questions or comments, bring them in now and we'll try to get to those.
Is there a way to, how can we make our moon rotate? So the moon, I mean, the moon does rotate. It just rotates at the same rate that it revolves around the Earth, right? So, you know, as it goes like around here, it looks more like a gear, right? So, but it's turning. So it's always kind of facing us.
That's why we always see the same face. I mean, you have the libration, as it's called, where you can see a little bit on one side or the other, but we see the same face, and that goes back to the formation of the moon.
Well, it's not all. I mean, the moon does wiggle, right? And its wiggle is slowing down as it gets more and more tightly locked as it moves further away. At the moment when it's furthest from us, when it's kind of stops going away from us, is the moment where it will stop wiggling. It's due to it's still moving away that it's got that little bit of a wiggle to it. So in theory, when it was a lot closer to us, you probably got more of a wiggle.
And then the reason we see that same face goes back to the origins of the moon, when the moon was not solid yet, and the heavy minerals, the gravity of Earth pulled the heavy minerals to one side, and everything solidified. And so it's those heavy minerals are on Earth's side, so it's always pulling. And so we always see that face, and that's not uncommon in the solar system with other moons.
Like a weeble wobble, do you remember those?
They wobble, but they don't fall down.
Yeah. So it's like that, but because there's an offset weight inside it that's pointing towards us. So the moon wobbles, but it doesn't fall around. Best pun I got.
Speaking of which, what do you call a meal from the moon? A satellite dish. Yes. The pain. What do you call a tick that lives on the moon?
What?
A tick. A lunatic.
See, this is just bad. I love
These are like from my granddaughter in 3rd grade.
These are great. This is my favorite. If you don't get a groan from a joke, or like if someone doesn't boo your pun, then did you even do it? You know?
Why did the Earth make fun of the moon? For having no life.
Well, those tardigrades.
Yeah.
Maybe.
And you know, I think it was William Herschel who thought there was some sort of life there, like ants, and we know there's not. But there have been others who thought there might have been some sort of life there. And certainly the ancients, well before telescopes, they looked at the moon and thought they were oceans. They were big circular areas that were dark. They look like oceans, and they kind of are. They're oceans of solidified rock.
Yeah, super mythic, very flowy lava. Although, so you see these weird, fun island chains in the Mar, and some of them are from the highlands, like poking up out of the Mar, like as if it were the lava were water that has floated around and made like a little island chain. And some of them are just, it's floating in these cool rafts on top, because that plagioclast, this stuff it cools quickly and it's light in comparison to this basaltic stuff. that makes up the dark area. So it would float to the top. So sometimes they're like island chains poking out of some deeper surface, and sometimes they're like rock rafts floating on an ocean of lava, which is real metal. Let's see what else we got.
We've got about 5 minutes left, so send those questions in.
Yeah, we're kind of.
And again, I'd like to thank, we've had so many people we've worked with. McDonald Observatory has been great. We've been sharing views all night. Others that have been involved with our partnership, Grand Canyon Conservancy, Arizona Science Center, Arizona State University, who you and I had tied in with earlier, Astronomy Association of Arizona, NASA, several observatories around Chile, and of course we said McDonald Observatory before. And we've had a lot of other people come tuning in also. Did you have a question?
This one, it's almost blacked out now on my side. Does that mean the moon is passing Earth? I'm not sure. I think that's mostly clouds.
And totality started ending just a minute or so ago. And so we'll start seeing the lower left will be lighting up, and you can see it's definitely lighter down there. Well, any redness that we saw is kind of going away, and it'll be back to kind of a normal color.
And I believe the stream will be online still after we're done. So if you want to check it out from the very beginning, answer all those other weird questions we got earlier. And then always, feel free to shoot us a line here at Lowell Observatory. Someone will probably answer you. Yeah. We like chatting. We like answering fun questions.
Any more coming in? Well, while you look at that, why is the dark side of the moon dry? Because the other side has all the moonshine.
Yeah.
Now that was not so good.
That's pretty good. I dig it. Let's see.
Why doesn't the moon shave? Because it waxes instead.
Let's see. So at the hospital.
I heard laughing in the background.
Oh yeah, it's gotta be. Gotta be for sure. Yes, 4 minutes. At the hospital, we schedule more staff when there's a full moon. Yeah, so like there's a lot of mythology around things happening during the full moon. Stuff, werewolves and witchcraft and things like that. And a lot of it though is like when the full moon is out, you can get up to no good later, and people get tired and weird later in the night, right? People can see a lot easier, so they get up to no good. And then as far as like seeing stuff out there, like, whoa, you see a lot more animals go crazy. It's like, you can just see them now, that they've always been there watching you, but now you can see them because the moon is very bright.
That reminds me of the Wolfman saying, even a man who's pure at heart and says his prayers at night can become a wolfman when the wolfbane blooms and the moon is full and bright.
Yippee.
The old Wolfman movies, the Universal monster movies. Oh, 3 minutes to go. So we'll look for one last question if we have any.
Where's the best telescope / observatory in the US world? I would argue that we're the best observatory.
Yeah, there are different ways of answering that. And I'd like to say they all say Lowell. There are really so many great observatories, but you go on a trip somewhere and, Lowell has such great history and it's fascinating. I mean, Pluto was discovered here, the first evidence of the expanding universe. But, when you go somewhere, you only have so much time for certain things. So there are a lot of other great places in Flagstaff, for instance, that you can learn history. But looking through a telescope, there aren't a lot of places. You go to McDonald Observatory in Texas and Kitt Peak in Tucson. I'm not sure if Kitt Peak's back open yet with COVID, but there are some places, Lake Observatory, that does, like us, as history, research, but they still open their telescopes. It's really you know, you can, like I said, you can go a lot of different historic sites, which are great. I'm a historian, I love it. But if you get a chance to go to an observatory, we of course are partial to Lowell, but Palomar, Lick, some of the others we've mentioned, they're all fabulous. If you get a chance to go to one of those, Cincinnati Observatory has the oldest observatory in the United States, and they do public viewing. And so if you get a chance, even if you can't make it to Lowell, try to get to one of these places. It's really a lot of fun.
All of these observatories have very unique specialty. Like we all specialize for sure. Yeah. And so you're going to get something different out of it everywhere you go. We all have really cool histories and things like that. It's like saying, oh, what's your favorite Pokemon? They're all great. The answer's Tangela, but they're all great.
And Lowell is unique, I think, because, you know, we've been around since 1894, which if you go to the East Coast isn't old. If you go to Europe, it's laughable. But for the American West, it's old. But we have a heritage of cutting edge research, discovery of Pluto, and so on. But also we have cutting edge research still going on with one of the most powerful telescopes in the world, the Lowell Discovery Telescope. But we also have this character, our founder, Percival Lowell, who was from a mainstream family but had not mainstream ideas about astronomy in some cases. And he's entombed on site here. And so, you know, here at Lowell, we talk about the Lowell family and we talk about Uncle Percy. It's a place of business, but it's a home to so many people. And it's got a personality. You walk around up here and it's a personality. And so it's one of the things we love about it. And I was just noticing it's 10 o'clock.
Oh, yeah.
And so I think we'll cut off here, but before we go, first of all, we're going to continue our live feed for the next couple hours so you can see how the moon comes out of totality. And if you want to watch other programs, we talked about the Star Stuff podcast that you can listen to that we're doing regularly. And we do these live streams pretty regularly. And of course, programs here at the observatory. And we're open virtually every day. And I just wanted to end by thanking our behind the scenes crew. We have educators who have operated the telescopes up here through the clouds, and they're working with our visitors who are on site here, but also our marketing team, our head of marketing, Daniel Adams, and Cody Halfmoon, who has spearheaded this event and has the perfect name for this event tonight. Sarah Gilbert created the graphics, like the logo for what we're looking at tonight. Heather Craig, Maddie Mooney, Alex Gilbert, Nate Nice were all on hand and doing this event. They have so many computers running. When we walked there earlier, the Brain Center, it's remarkable how they've kept everything going. So we'd like to thank the team behind the scenes for making this happen, and thank our donors and the friends of Lowell Observatory for making this happen, allowing us to do this, and of course our viewers for joining us.
All the educators down there, and then the supervisors squad is doing an amazing job wrangling the crowd tonight and coming up with some really cool programming and working these telescopes for us and doing great stuff. I really appreciate that.
They've got their steps in today.
Yeah. He was just saying like he's 200% over his goal or whatever tonight already. Nice. Like, but yeah, appreciate you all viewing and hanging out with us. It's always a fun time.
Thanks, and enjoy the views for the next couple hours.
Bye, nerds.
Hi, I'm Gav Moriarty. I'm an educator here at Lowell Observatory. These missions are just about to start, and by soon I mean like this year. At the end of April, NASA just completed their wet dress rehearsal. This is exactly what you think of a dress rehearsal, with taking the rocket onto the launch pad and going through all the motions of a real launch, but the wet part of it means that they fueled the rocket, and so they could actually test all the fueling systems before launch as well. And it's a good thing that they did, because they did find some problems and they're currently already fixing them, and so we're expecting a launch in August of this year, somewhere around there. So what are these missions actually going to look like? The first one will launch in August of this year, and that'll be an uncrewed mission where the Space Launch System, the new rocket that NASA is going to be sending up, will have the Orion capsule on it, and they're going to do an uncrewed mission that will last about a month, just going through the orbits of the Earth and the Moon. And then in 2024, we'll get the first crewed mission. This will be called Artemis 2. And this will act the exact same as the uncrewed mission, going around Earth and the Moon as flybys, and will still last about a month. And then the best part, in 2025, we'll have Artemis 3. That is going to be the crewed mission where we will land on the Moon for the first time since 1972. On that mission, 4 people will launch in the Orion capsule, and 2 of them will be chosen to walk on the surface of the Moon. They'll spend about 6 days there doing scientific observations and testing out some systems. And hopefully, if all goes well, we'll get more missions following Artemis 3 in 2025. That's not the only thing that NASA has planned in the coming future. As well as the Artemis mission, NASA is also planning to build their Lunar Gateway Station, which is going to be an orbiting space station around the Moon that will be a checkpoint for future Moon missions and for hopeful human deep space travels. And so they're already building pieces for that. We're hoping the first pieces will go up in 2024, and the important pieces, with including the human landing system, will be there by the time Artemis 3 reaches the Moon in 2025. And then after this, they'll keep adding pieces onto it, more science, propulsion systems, and my personal favorite, the Canadarm3. Away from the Moon, NASA also has the Psyche missions happening. And so the Psyche is actually an asteroid in the asteroid belt that we think could have actually been the core of an early planet of our solar system. And so the Psyche mission is currently in development by NASA's JPL, or Jet Propulsion Labs, and is being tested for hopefully launching at the same time as Artemis 1 in August of this year. And so that'll take a couple years to get to the asteroid in question. It'll do a little slingshot around Mars, a little flyby, and then it'll meet up with its asteroid in 2026. And then it'll spend about 20 months or so orbiting around this asteroid and mapping it out, trying to study the properties of it so that hopefully we can understand a little bit more of what actually happened in the early solar system. There are plenty of awesome missions that NASA has in store for us in the future, so keep an eye out to learn more about what is currently happening in the realm of human space exploration. Thank you to our members and donors for making this video possible.
Hello
Hi, I'm
everyone,
Giovale
my name
Open
is Matt. I'm an educator here at Lowell Observatory.
We're just around the corner from the
hope you all
biggest
are
human space
enjoying
exploration
the
in
Lunar
over
Eclipse.
50 years.
I'm going to talk to you all
Artemis
about
mission will be the next step in human space exploration. By 2025, NASA plans to land the
I hope you all are enjoying the lunar eclipse. I'm going to talk to you all about the moon and the tides. So what exactly are the tides? How I like to think about the tides is the rising and lowering of the level of the ocean. So during the day you'll have high tides, which is going to be the highest point that water reaches along the shoreline, and then you'll have low tides, which is the lowest point that water will reach along the shoreline. And each day you'll have 2 high tides and 2 low tides. Now what exactly causes these tides? What causes the water to move like this? Well, the main contributor is the moon, specifically the moon's gravitational force on the Earth. So if we look here, we can see these arrows on this diagram. These arrows represent the gravitational pull of the moon on the Earth. On the side of the Earth that's closest to the moon, there is the largest gravitational pull, and we can see that with the largest arrow. And as you move away from the moon, the arrows get smaller and smaller because the gravitational force of the moon on the Earth gets smaller and smaller. Now if we go ahead and insert the tidal bulges, we can see that on the side of the Earth closest to the moon, there is a tidal bulge. And this is because the gravity is stronger, so the water gets pulled to the moon. So you end up with a bulge of water. And this is going to be one of your high tides. Now on the opposite side of the Earth, there's actually also a high tide, which is kind of counterintuitive, and it didn't make sense to me at first. There's a couple of ways you can think about it. How I like to think about it is the moon is kind of trying to stretch out the Earth. Since it's pulling on different areas of the Earth with different strength, one of the results is that the Earth is going to get stretched out or elongated. Now what this means is that you end up with a bulge on the side of the Earth that's closest to the moon and a bulge on the side of the Earth that's furthest away from the moon. Another way you can think about it is the gravitational force on the far side of the Earth is so weak that the water doesn't really move. It doesn't really experience a force that would cause it to move, so it kind of just stays there and you end up with a high tide. Now, the moon isn't the only thing that exerts a gravitational force on the Earth. We also have the sun, the object that the Earth rotates around. And since the sun exerts a gravitational force on the Earth, you end up with tides from the sun as well. So I'm going to go ahead and insert the lunar and solar tides. Now, since the sun is so far away, the tidal forces from the sun are about half as strong as the tidal forces from the moon, so you end up with tides that are about half as high. Now, we start here in third quarter. In third quarter, the moon and the sun are not aligned, meaning that the tides don't line up. In this case, you're going to end up with neap tides, which is gonna be when you have the lowest high tides and the highest low tides, because the tides of the sun and the tides of the moon are not lining up. Now if we continue through the lunar cycle and we end up at new moon, now the moon and the sun are lined up. And when these two are lined up, the tides are lined up. This is when you're going to end up with spring tides, which is going to be when you're going to have the highest high tides and the lowest low tides. If we continue through the lunar cycle, next up is first quarter. We're once again going to have these neap tides where the 2 tides do not line up. And then we end with full moon where the tides are lined up once again. And this is where we're at right now. So if you were to go outside tonight, or if you were to study the tides over the course of the next day, you're going to have the highest high tides and the lowest low tides. Now let's get into something called tidal slowing. As the Earth rotates, it actually brings the tidal bulge with it. So if we
play this, we can see that as Earth rotates, it rotates the tidal bulge away from the moon. Well, the moon doesn't like this. The moon wants the tidal bulge to be lined up. It applies a corrective gravitational force, trying to pull this bulge back to being aligned with the moon. And this gravitational pulling actually pulls against the rotation of the Earth and slows it down. Every day, this tidal slowing slows Earth's rotation by about 500 billionths of a second. In order for it to slow the Earth's rotation by a single second, you'd have to wait 50,000 years. So not something we're necessarily going to note, but it is a cool phenomenon caused by the moon's gravitational effect on the Earth. I want to thank our members and donors for making videos like this possible and live streams like this possible. So thank you.